By the 1930s, aircraft design had completely outpaced naval defenses. Warplanes were flying faster, higher and with more maneuverability than ever before. The defensive strategies developed during the First World War couldn't track them. Navies tried to fight back with light 20mm machine guns. These fired quickly, but the small bullets lacked the explosive punch to physically destroy an incoming bomber before it drops its payload. On the other end of the spectrum were the heavy 5-inch artillery guns. They had the explosive power to tear an airplane apart, but the heavy turrets were far too slow to track an agile diving target. This created a lethal mid-range gap in fleet defenses. Dive bombers and torpedo planes could easily slip past the slow artillery and survive the light machine guns, leaving the entire fleets exposed. Surviving this threat required a completely new class of weapon. In 1930, a Swedish company named AB Bofors developed a solution to this exact problem: the 40mm L60 anti-aircraft gun. The engineers faced a massive physics problem. The 40mm Bofors shell weighed 2 pounds. Cycling the heavy cartridge like that at high speed generated intense recoil and vibration, forces that would normally tear a rapid-fire mechanism into pieces. The solution was a top-loading hopper. Loaders dropped clips on top, using gravity to drive the heavy shells downward and cycle the breech. Because gravity did the heavy lifting, the gun fired continuously, achieving a sustained rate of 160 rounds per minute. Combining the firing speed of a light machine gun with the destructive power of heavy artillery, this Swedish design finally gave the navies the precise tool they needed to protect the skies. But there was a severe bottleneck. The Swedish manufacturing process relied on highly skilled craftsmen hand-fitting unique parts. To meet the global demands of war, the United States turned to its automotive industry. The Chrysler Corporation was tasked with taking this boutique European weapon and rapidly scaling it for mass production. The first hurdle, Swedish plans were in metric, but the American tools used imperial units. Engineers translated every dimension into inches. They also standardized the hardware, redesigning the weapon with interchangeable parts so thousands of subcontractors could manufacture components that fit flawlessly together. The results were staggering. Assembly time plummeted from 450 hours per gun down to just 10 hours. By the end of the war, American factories had produced over 60,000 units. Through mass production, what started as a rare, specialized weapon became a universal defensive shield, mounted on nearly every Allied warship that sailed. Even with the fast-firing mass-produced gun, scoring a direct hit on an airplane was still very hard. Standard ammunition relied on contact fuses, which required a physical strike, or mechanical time fuses, which required guessing the exact altitude of the target. By the middle of the war, the crews faced heavily armored dive bombers and extremely fast, aggressive attack profiles. There was absolutely zero margin for error. To close that margin, the Applied Physics Laboratory and a highly classified team known as Section T developed the VT, or Variable Time Proximity Fuse. Inside the shell's nose was a miniature radio transmitter. As it flew, it continuously broadcast radio waves forward. When those waves bounced off a target, they reflected back. Once the signal reached a specific intensity, it automatically triggered the explosive. A direct hit was no longer required. By automatically detonating the moment it entered the lethal proximity of a target, the VT fuse turned narrow misses into highly lethal shrapnel clouds. The combat data proves the effectiveness of this system. In the Pacific Theater, the 40mm Bofors alone accounted for 1/3 of all Japanese aircraft shot down by the United States. When the Axis deployed desperate late-war tactics like the Japanese kamikaze attacks and the German V-1 flying bombs, the combination of Bofors' fire rate and the proximity fuse's accuracy was the only defense fast enough to neutralize them. The core engineering of the Bofors was so sound that it never really retired. Upgraded versions of the weapon like the L-70 are still active today, mounted on modern combat vehicles and Air Force AC-130 gunships. Securing the skies didn't come from a single miracle weapon. It required Swedish mechanical ingenuity, American industrial might to build it, and advanced radio science to ensure it never missed its target.